Hey, what's up, fellow YouTubers? So today I wanted to show something that I've been working on. So I've been working on planning on doing a whole bunch of programming related to creating console app games, and I decided to start with one of the actual tougher ones, only because that one seemed like a lot more fun. And you can see a lot of the code here. I have the link below in the description, and it's out on GitHub. So one of the things about this is that I had to create a lot of different classes. It's basically a slot machine, and so we have things like the reel that handles all the real stuff. You know, like a reel goes up and down and has so many symbols. I think in my case it has something like 22 or 23 symbols, and then it has it needs to have also a pay strategy. So you can see the pay strategy here, and not a lot to the pay strategy. It just has to pay out depending on the symbols. And now this goes by rows, right? So you have the top row, the middle row, and the bottom row. So I pass that to the payout, and the payout decides what it's going to pay out. And I could have just wrote the code and gotten right into the main and started creating the code, but you can see that I have nothing in the main yet because I haven't started putting it together. I started kind of working from the bottom up, all the basically all the core classes, all the slot machine classes that are going to enable me to write the code to make this work, all the little components and stuff like the purse. The purse is, for example, something that would just take and have the balance. It keeps track of how much money you've added or funds you've added, how many bets you've placed in total in amount, how much you've actually won, and how many withdrawals you've made over the time. So it has a ledger also to keep track of everything that's happened. That's in case a malfunction or something, we can go back and dump the ledger. So with that, since it's C++, we have a copy constructor. We have just a regular constructor that initializes everything, but then we also have the copy constructor that'll copy everything over, and also an assignment because we may need to pass the purse around later on. And so copy constructor and the assignment constructor, not the assignment constructor, but assignment operator look pretty much the same. And of course it gets the balance, and based on, it doesn't keep like a running balance. Basically it's calculated based on if you made so many bets, what's your total wins and your total withdrawals, then it'll keep, that's how it figures out the balance, right? Because my objective later on is to actually save this. So that way we can save all the information related and maybe even put it into a high score or something. Now with the purse, you can actually place a bet. If you actually have enough to place the bet, then you can place the bet. Notice that I'm adding this is just a way to add it to the ledger. String stream is a simple way of actually formatting the string, because I don't know of any other better way to do it in C++. I know in C you can do like you can do sprintf to format a string and combine literals with values. This is just a way of doing it in C++. I push everything into the string stream, and then I take that, whatever I added to the string stream, and push it to the ledger. And now if you didn't have enough to place a bet, then it'll actually log that as well. It'll just say that you didn't have enough to place the bet. And of course, collect win, it'll just take and add whatever you bet into the total wins, and it'll log that as well in the ledger. Then of course you can add money. So total, it'll go into total adds, because you can always add more money into a machine. This is to kind of help you track if you've actually won or if you haven't, if you're actually losing money when you play. And of course, there's always the cash out. You can end up cashing out, at which point, if you cash out, it'll take all the money out. It'll still have your wins, but your withdrawals actually, it'll take it from the balance, and so your balance will be different All right. So you usually don't cash out to the end of the game, but like in the real world, sometimes people cash out and then they put some more fresh money in. So there's also a clear just to clear everything, and it just lets you know that it was cleared. So to make a lot of these things work, especially for something like this, the pay strategy, if you look at the pay strategy, I have all these symbols. And if I look at the pay strategy, it's a very simple class. It just has the pay mappings. In other words, what symbol and how much does it pay if you get all three in the pay line. It has the pay mappings. And we also have, now the pay mappings get initialized in the constructor, and it has the payout, and it also has the pay tables, because sometimes you want to know, like in the game, like what are the payouts. So that's going to display the payout. So if we go to the actual CPP, if we want to notice I have some classes that some functions that are not part of the class, and the reason for that is because it just doesn't need, these things don't need to be part of the class. This certain some simple things, like if actually all symbols indicate that they all match, this is that all three symbols are the same. Contains a multiplier. In other words, if there's a symbol in the pay line that's a 2x or a 3x. So if symbol 1, 2, or 3 is a 2x, or 1, 2, or 3 is a 3x, because that's going to be a multiplier, right? So now in order to get the multiplier, we look at the symbols and we calculate. So you may have a 2x and a 3x, and let's say, for example, a $sign. So whatever the $sign pays out times the multiplier. So you notice the multiplier is, it's kind of progressive. It'll multiply if it finds a 2, and then if it finds another 2 in the other symbol 2, then it'll add that multiplier there, and then it'll just keep using the multiplier. By default, the multiplier is 1. That's, of course, if they all match, it's just a value of 1. It can't be 0, because then you end up with a 0 winning value. Now, when you do the payout, it checks to see if all three symbols matched, right? And if it does, it just returns whatever the mapping is to the payout. And we'll take a look at the mapping in a second. Now, if that's not the case, if instead it does contain a multiplier, we look at the multiplier. If the multiplier is greater than 3, in other words, a 3x will get one symbol, a 2x is one symbol still. So we just look to see if we have a multiplier in any one of those. And if it has a multiplier, we take the multiplier times whatever the symbol, right? Now, if it's greater than 3, it means that you probably had two multipliers, a 2x and a 2x, or a 2x and a 3x, or a 3x and a 3x. So therefore, we pay out based on the multiplier plus the one symbol that is not a multiplier. In other words, the star, the at, whatever, and whatever that pays out times the multiplier. On the other case is if we have a multiplier, if it does contain a multiplier, and at least two of the symbols in the pay line match, like 1 and 2, 1 and 3, or 2 and 3, if they match, then we check to see the one that is not the multiplier, because we know that at least 2 matched, right? Because we did check already that they match. Here we check to see that we have at least 2 matching symbols. We'll multiply whatever symbol is not a multiplier times the multiplier, and that's all this does. But of course, I can be confident that it works, but it doesn't mean anything, because I still have to test it. There could be typos. There could be anything that prevents me from actually validating that my code works. And I just kind of commented here what each pay line, what it pays. So based on the bet, for example, if you bet 4 times 2.5, that means you only won 1. Yes. In slot machines, you can actually win less than you bet. It's kind of a sad story, but that's what it is, right? Sometimes you actually only win what you bet, so you're actually back at 0. And sometimes you win 1.5 times. So these are all the different pay lines, right? And so in some cases, if you have like 2x all the way across, then it pays 400. If you have, in this case, let's see, 3x all the way across, it pays you 2,700. And if you have if it's 3x anywhere, like anywhere on the screen, but you get 3, then you will get 1350, right? So then, of course, these are pays 10 times, 20 times, whatever you bet, and so on, right? So now we have the pay mappings, right? We have all the pay mappings, and of course, an empty space. There are empty spaces in our symbols, so they don't pay anything, right? So if you can match all three symbols, but they don't pay anything. So now to get the payout, you pass in the symbols, and of course, that logic is actually up here where you actually get the payout based on the mapping. So you get the payout, and where's the payout? So here's where the payout is, and this is what's going to return the value that you actually won. So that's all that I need for the pay strategy. And I needed to have it separated so that it's not coupled with anything else, output or anything like that. I do have the pay line tables, and they just kind of push out what they are. So this will actually just give you what the payout tables are, and it can display them. That way you know what you're playing against. So when you spin, you can already know, if you can memorize all this, what you're actually winning. Of course, we have a H. In some cases, I decided to just go with the HPP file, which it doesn't make a difference if you say HP or HPP. It's just that when I say HPP, it means that I defined everything inside the H file, and that way I don't have to create a separate CPP file for it. So the purse keeps track of everything. So how do I test that? Well, for a lot of that stuff, I created a separate, which is a separate folder to run my tests. And what I did is I created a framework. I created it, and it's not really even so much a framework. It's just a very simple tester class. And if you look at it, the tester HPP, when it gets into the class, it's a class called tester. It needs to know the category. It needs to know which test passed and which test failed. You can set the category. You can have tests for equality if you expect something and then an actual, but you notice that I use some helper functions that are defined up top. Basically, expected, actual, the name, the category, and the pass test and the fail test. The reason I need to pass the fail test and the pass test is because it needs to add them. And since they're not, this is not part of the class, I need to pass them in. Otherwise, I wouldn't need to. But since they're not part of the class, when I say assert equal, I need to pass those in, because what I'm going to do is I'm going to add to the pass collection that the test passed, right? So the test passed, I'm just going to push it back and say that the test passed. If it's not, and if it's the same, I'll just say whatever test passed. If it's not, if it didn't pass, that's where I'm going to say that whatever category, whatever name, whatever in the category is probably going to be like the name of the class under test, and the actual test name would be whatever test you gave, whatever name you gave the test, and it'll tell you what it expected and what it actually was, and it puts that on the failed collection. So if you pass collection, if you failed, it'll put it in the failed collection. And there's something also for not just equal. Notice that also that this is a templated function, so this will work on anything that has the equality operator available to it. In the case of strings, integers, doubles, floats, anything like that is already there. Now there's another assert true if the condition is true, very similar to the other ones. If the condition is true, it'll just work there. And then if it doesn't, then it'll tell you it failed in the condition. It was expecting this, expecting true, but it was false. And then there's an assert false, because sometimes you want to just assert that something is actually false for whatever reason. So that's really all there is to it. Notice that I did a whole bunch of overloads. Now, the reason that I didn't make this generic is because I'd actually need to be able to have an assert for int, an assert for char, an assert for float, and assert for double. Otherwise, I would have to create a class for each one of them, and I don't want to do that. The function itself, it just, defers to that function, and it handles whatever that is, since that one's already actually generic. It's a or template, and it can tell you how many tests passed, how many tests failed, just by how many are in the collections. And then you can actually get the results. Notice that I don't actually display the results to the console. I use string stream. And of course, one thing I didn't say is that you have to include stream for that. And of course, vector for vector and IOStream for output. So now when I actually get the results, I output a line, I say what category, and I tell you which tests passed, how many tests passed, how many tests failed. And if there's any failed tests, I output them to the, not output them, but I add them to the string stream to tell you that, hey, this test failed and here's why. Basically, since I actually have strings and failed tests, it's just a string saying such and such test failed and it expected this and it was actual that, and that's all it does, right? And then it returns the string that is composed of all those strings. Now, when you get into the test itself, for example, let's go over the pay strategy, which is something probably the more complex ones. Notice one thing that I have just an HPP file here. It's just a test HPP, and I named it according to the project and the class, and I say, okay, the age, I define it. I know I'm going to need string and IOStream and vector, and I include the classes based on their location. This is common with any other applications that you might have worked with, like anything in Node or anything where you say, hey, go up 2 directories. And if I go up 2 directories, it's going to go up 2 directories and then go to include tester.hpp, which is here, and then also include, go into slot machine core and get the pay strategy.age, and that'll allow me to use that information. So in here, for example, in the pay strategy, since the pay strategy is under class, so I create an instance of it, and I need to know what's in each row on the board in order to run all these tests. And I kind of copied the the values for what their payout is so I could test them. So my initial test, of course, before I even do that, I set the category. Since my pay strategy test inherits from or extends tester, then I have access to set category and test and all that. I added another function here called prepare row pay line. And so basically, since I'm only at this point, I'm only through the test where I'm testing just that middle row. So if I had 3 rows, one row with the payout, another row with the actual win line, and then the bottom row, which is not a pay line, I'm only interested in that second row. So that's what I compare, right? So I set it, I prepare the row. And in all of these tests, I always prepare the row. I say prepare the row pay line, which in this case is for at. I'm checking to see that it pays out what I say it should pay out. So I say payout. I call the pay strategy, and it should tell me that I won 0.25. And I name my test according to whatever that combination was. And same thing for all of these. I'm just testing all the different symbols. I tested all the symbols. Down towards the bottom, then I have to actually check to see if that 2x multiplier is paying. So for example, for $, it's 20. If I $, it was 20, but since it's 2x, it multiplies it times 2, so my payout is 40. And I put the 2x in each one of these. So if in this case, it's at the end on the last column. On this one, it's on the middle column, and on this one is on the first column. They should all work. And I just name my test according to that. So then I do the same thing for the 3x. And then now for the 2x, what if I get two 2x symbols, right? So it should be double what the double was. So that's 80. And I check it the same way, make sure that it works. Now, when I was doing this, I was using TDD to do it. I would write a test, make sure it builds, get enough to pass, and then run the test. And in order to do that so that it runs it really fast and efficient, I created a way to run these tests Notice one thing about it though, is I create all these tests. Normal frameworks will automatically pick up anything that's a test, and usually they're decorated or it'll be named test or something. I didn't have that luxury. Since I created my own, what I do is I run each test. I tell it to run each test. So for example, you'll see this test, paste 3 eggs, anywhere combined, you'll see it way at the bottom. And so when they actually do the assertions is when it'll add it to the collection of tests. Now that, once it runs all the tests that I told it to run, I can get the results. And of course, get results is just, if you go back to tester H, it just, under get results, it goes and outputs all the tests that passed, all the tests that failed, and it outputs also the tests that failed, but it doesn't output them, it just returns them as a string. That's why when I go to back to the strategy tests, I get a string and I just output it. Now, what enables me to run these tests simple and easily? Well, all I have to do here is I have to tell it all the files that I want to compile using the G++ command. This is just a batch file, right? So I tell G++, compile the real CPP, compile the machine CPP, and the pay strategy CPP. Any HPPs, I don't have to tell it to compile. As long as they're referenced, like if you notice, like for the purse is not here. Well, the purse is already part of the purse test. It includes the purse HPP. So when this compiles the purse test HPP, when it compiles, it'll automatically compile that. And notice that I don't have the purse test HPP on my piece. I only compile the CPP. Well, what's the CPP that it compiles? It's the main CPP. And the main CPP calls the purse test HPP, so that's what's going to cause it to compile. Now in the main, all I do is I create a vector of pointers, tester pointers, and then I just instantiate the class, and I push the class as a pointer. You know, notice I'm passing the address to the test, and I do that for every test. So if I was to add a new class that I needed to put under test, then I would have to add it here as well. And then I just tell it to run the test. I pass it the test, and when it runs the test, it'll keep track of the total tests, pass, total test fails. First, it goes through all the tests, right? So it says for every test in test is like a for each in other languages. It'll do a run on the test. Now, when it runs the test, then that test will know how many tests passed, how many tests failed, right? So it has that information there. So then that way I know how many tests passed. And so it'll say the total number of tests. Of course, the total number of tests are total tests failed plus total tests passed. That's my total. And then I'll have total tests passed and failed. So, and just by running that, notice that I run that and I create the file and I name it test.exe. Then this is the way to run it in Windows, right? Because in Linux, you would actually create a different file and you would probably say // like that. But in, oops, not like that, but like this. And so, yeah, that would run it. But this is not a Linux system. This is a Windows system. So I have to do that. And then I just delete the file because I don't want to deal with it. Once they run, I'm done with that file anyway. So I just run it. So now if I go back to my command line, all I have to do is build and run. And let me increase the size of this so you can see everything better. I just go ahead and run it. And then it tells me what tests pass. Of course, not all tests are passing. For example, for the real, they all pass. For the machine, they all pass. All the tests that I have, 0 failed. For my pay strategy, it's one that failed. Notice the one that failed gets output to the bottom here. And that's just saying that it failed because I need a test for this. And I actually put that in there. If I go to my pay strategy test, it's more of a to-do than anything that I added a test when there's a 3x anywhere because I haven't implemented that. I just said I need to put a test there because this actually has to be tested at some point, and I'm just making it fail so it catches my attention, and I need to go back and fix it. Right now, I say assert true, but I pass it false, so therefore it causes it to fail. I need to pass that. Same thing with another test down here that's the pay strategy, and there's one for the machine interface, right? Because I just started coding the machine interface, which the machine interface kind of brings it all together, but it's still not a UI. It's not UI centric or yeah, just user interface centric because and this, I'm surprised that this is compiling because that should be machine interface. And so I haven't coded that. And so I wrote some of this code, but I haven't tested any of it, and I need to make sure that I test it. This is going to be like the main interface that the game interfaces with. You may be wondering why I did it this way. And part of the reason why is when I started thinking about it, it's like, okay, I need to be able to pass all the information, but this is kind of like the entry point into the whole game. But I didn't include it. I didn't include any kind of user interface with it. Well, what I plan to do is I plan to put it in the machine UI. So my code for running the game will be in here. I probably will create a game class that uses the machine interface. I just want to make sure it compiles, but the game will actually have access to the machine interface, and it'll have all the game logic. Well, not all the game logic, but a lot of the logic to say, hey, they spawned, they did whatever. And then I just display the information that the actual slot machine code provides, but it'll be more very anemic. It won't have a lot of logic. All the logic will be done by the slot machine core stuff. This will just be kind of a way to, they don't have the stuff to display to show maybe the menu to say, you know, at this point you can add money, cash out, change your bet, spin, and it'll also display whatever actually spun. If you notice in the slot machine logic, when the machine interface, it can check to see if you can even spin, otherwise it doesn't let you. But if you do spin, it checks to see if it can spin, and it'll spin and it updates the bet with the current amount. It updates the purse. It spins the machine. It gets the data. It knows based on whatever spin data it put out, it knows how much it won. It updates the purse with how much you won. It updates the spin data DTO with whatever information. And it's going to, and this should not build because I'm not returning. Oh yeah, no, I am returning spin data DTO. So I return the spin data DTO saying, hey, this is the information based on that spin, and then they could use that information to populate the user interface. There's also a way to update if you're refreshing or something to get the screen data DTO. My plan really is to see if I can build this application so that I have a console UI, but after I build a console UI, maybe take on a bigger challenge and create an actual graphical user interface. And that I can probably use like SDL or something, but I can reuse all of my code that I have for the logic to actually do it. So the actual SDL UI code will be very minimal, and it'll actually just worry about rendering and stuff like that. But all the game logic will actually be out here. Notice the other thing is part of the reason that I separate them into separate folders is because when I build something, I can tell it to build all CPP, but it's only going to build whatever's here, not anything else. And, you know, in a C++ application, you can only have one main, right? So that's part of the reason of separating it. And then everything can run independently, where I can run this main and run the tests against it and all that. But, you know, actually this would run the game. If I wanted to run tests, I would probably create another, maybe this is for the slot machine core. Maybe I want to create some tests for the for the UI. So anyway, very, very simple stuff. I think we can probably add just as an addition here. So let's say that I wanted to add a test just to kind of see how I would do it. Let's say I wanted to add a test for machine interface, and I coded a lot of the machine interface, which I should have done the other way with TDD, but it was just so easy to put stuff in there that I went ahead and started doing it. But let's say that I wanted to see if I can spin. Let's see if I can spin. It should be false because initially my purse is empty, right? So since my purse is empty, I should not be able to do that. So now when I try to run the machine interface test, which I have the machine interface here, I want to create a new test, and I want to see can spin should be false on empty purse, right? Because I don't have anything. So now what I'm gonna do is this. Before I do that, let's say that I set my machine, my bit. I think the machine interface, if I'm not mistaken, if I look at the machine interface, the current bet amount is 1. So it already knows to bet 1 if I haven't set it. So when I go to the machine interface test, I'm going to say machine can spin. And actually I can put that here. And you can name your test whatever you want. In this case, I just say machine can spin. And so it'll tell me if it fails, it'll tell me, right? So I have this test. Now I'm not done there. Like I said, in other frameworks, this would be done. You wouldn't have to do anything else at that point. But in my case, I have to add it to my run. So can spin should be false on empty purse. And I just add it. And now you notice, let's see, okay, so did I include all that? Yeah, I did that. So I need to save it. Now, the other thing is that machine interface tests need to be in the main. So let's see that they are in the main. So machine interfaces are in the main. Okay, and it should run them. So now let's go ahead and take this. Let me move this up a little bit so I can see it better. Close that. And so I'm going to build and run. Going to build and run. Let's see if it builds. If it doesn't build, we'll have to fix. Okay, there we go. So it says that machine interface can spin expected 0, but was 1. So for some reason, it's telling me that that test failed. And let's see where my machine interface tests are. Oh, is this what I was expecting? Test CXC, machine test, pay strategy test. Oh, there's another thing. Let's see. Let me see in did I set the right category for it? Yeah, no, it is the right category. Okay. So machine interface tests, both tests that I have there failed. And so that's what you can expect to see when they fail. Now, if I wanted them to pass, so that one I know is going to fail. So I can actually remove this test because we actually have starting to do tests on it. And so I need to remove that test. However, this one can spin should be false. So can spin should be assert false, not assert true. So we should assert false can spin should not be able to spin. So let's see if it passes now. And I just save it and I build and run. I build and run. And now we can see my machine interface test pass. So that's simple. Like I said, the link to All of this will be down below. If nothing else, you can always use this to add to your test and maybe copy something like this to separate your tests and run them. And there are options like Google Test for C++, and then there's Catch. I found that they're just overly complex. I don't need all that. Maybe in a production level C++ application, you might need them because they need to be automated and hooked and all that. Of course, they're more robust, but for what I'm doing, this is at least good enough that I can, with confidence, say that I've unit tested my code. Like I said, the link will be below for as far as the code, and so you can look through that. And if you have any questions, give me some feedback. I'd be glad to answer anything. Thanks for watching.